All right, so we finished all the sections for the class. So the following sections will not be on your final. And I will not be testing you on them. But the idea is to have you review and it'll prepare you for calculus 1. Okay. Yes. No. Final is the last one. You'll still have required homework for these sections, but it will not be tested. Okay. A lot of it will be review. Some might not be, I don't know. But this one is just quadratics. So do you remember how to put example 1? A quadratic into standard form? This one here. Once it's in that form, you can answer all kinds of questions like what's the vertex, what's the domain and range. Okay. For any quadratic, the domain will always be all real numbers, so there's not much you have to worry about there. The range will depend if it's opening up or down and where the maximum or minimum is. But to do this, you need to complete the square. So you must complete the square for to get standard form. Okay. So what I want you to do is just take the function, make a little space between the 10x and the 10, -10. You're gonna add a special number and then subtract that same special number right after. But when you add it to this piece, then you can factor it. Okay. So that special number, to complete the square, introduce b/2 squared here and here. That's all you gotta do. What I mean by b, I mean given the general form, the one we use for what's it called? The quadratic formula, the ABC. So just take this b, divide it by 2, or cut it in half, and then square it. That's the number that's going to go there. Once you've done that, this will factor perfectly, and you'll have some number left over. That's all you got to do. Okay. So for this case, right? Okay. For this example, b is equal to 10. Half of b is equal to 5. If you square that, the special number is 25. Right? So just add 25 here and then subtract it. Since I don't have two sides, you have to undo right away what you're adding. Yes. right? Because I'm not adding 25 to both sides, because I can't use this side. So I have to add it and then immediately subtract. Okay, I'll do. Add 25, subtract 25. But I'm gonna place it in a specific way so I can take advantage. Okay. So right here, you add the 25. Subtract the 25. Yeah. So the idea at this point is that this first three terms are going to factor perfectly. This right here, if you try to factor, it's going to be and then this number will just be some number. Okay. That makes sense? You just factor the first three there. So now we're in that form. This is the standard form. That makes sense? Is there any questions about the approach? Mm-hmm. Yeah, so that's the idea is you factor this, just do a trial and error. Once you have the 25, it's going to come out perfectly every single time. Yeah, just add them or subtract them. Don't mess with these until after you factor. Yeah, like we're basically moving this to the side, right? And factoring this. Okay. So this is the standard form. You guys cool with example one? So the first question will just start in the homework. We'll just tell you, put this in the standard form and give the vertex. Vertex is always going to be HK. From this guy. So just take the opposite of whatever H is, put it in here, and then write down the K. So our answer will be, in this case, right, -5, -35. So once it's in the form, you can answer and put it in the vertex. Whatever number's here, you make it down. And then whatever's out here, you just copy it. This is the general form, or the standard form. For H and K are different. This should be very familiar from back in the day. So the first few questions are just putting it in standard form, give them the vertex. And after that, they're going to ask for different things. Then they give you some notes. You guys cool on example one? All right. Yeah. There's no rush. Just let me know. All right. Example two. I guess let me hear the notes first. General form, as we said, is this guy. Standard form is this one. It's the same thing in two different forms, that's all, okay? Now, you can't find the vertex without going to standard form. Now, you could avoid it. The only time you can is when they want this, right, specifically. But if they only ask for vertex, you do not have to complete the square, right? So we know that the vertex, we said just a moment ago, is HK, right? But H is technically equal to negative B over 2A. And K would just be the function at that value. This is kind of like a formula. So you don't have to worry about just completing the square. So let's find this real quick and plug it in here. If it's in general form. If it's in standard, well, you already have it. The vertex. Okay. Yes. The function, f of x. So plug it in basically to get your y. You know what I mean? So this is your x value, and this will be your y value. Axis of symmetry. They asked for this. We mean basically it would be x equal to h. So the answer would be an equation, x equals, not the number h, just x equals h. It's a vertical line. Okay. So whatever you have for the vertex h here, that's your answer for the axis. It's just a straight line that goes straight through the middle of the parabola. Okay, that's all it is. Okay. All right. Max/minimum will occur at your vertex. So if they're asking for a minimum or maximum, just give them the vertex. Just make sure you know, is it opening up or down? Okay. The parabola will open up if A is greater than 0. The parabola will open down if A is less than 0. Domain for any quadratic will always be all real numbers. So if they ask for domain, you can plug in whatever you want. There's nothing that stops you. Right? You can square any number. Range will depend on if it's opening up or down. And the vertex. So it just depends, really. I would say graph it. So if it's opening up, then you know that the range will go to infinity, but there's a minimum point, right? So find that lowest y value, which is the vertex, and then just go up. If it's opening down, you'd have a negative infinity for your range, but you'd have a maximum value at the vertex. It just depends. So my advice for range is graph it and then just see how high it goes and how low it goes. So don't make it harder than it needs to be. Anyway, I think that's all you really need to worry about. Do you remember how to find intercepts? Maybe. I'll write the note just in case. You find x-intercepts. Set f of x to 0 and solve for x. To find y-intercepts, let x be 0. And that's it. Just plug it in. Just plug in 0. I think that's all I really need to know. Honestly. Is there any questions on quadratics? Okay. We'll move on to a different section and then we'll see how it goes from there. The next section is family of functions. Basically just a review. I mean, again, everything from here on is reviewed to prepare you for calculus. Those of you that got here later, there'll be no tests on it. It'll just be required homework, okay? It will not be on the final. I'm going to focus on pre-cal for the final. But don't skip it either. All right, so there's homework 20. This one's about just general polynomials. The homework starts off asking you to find the degree and the leading coefficient. So the first one just basically trying to see if you remember the jargon, I guess. Do you remember how to find degree and what degree means? Well, degrees will affect intercepts, but what is a degree? It does a lot of things, but degree on it's a simple concept. That's just what's the highest power? That's all it means, right? So degree is the highest power of your polynomial. That's it. So the degree here is 2. Leading coefficient is just the coefficient on the term with the highest power or degree. Do you remember what a term is? I use that word a lot. Yeah, like that could be a term. So how many terms do we have here? 3 of them. So a term is anything that's separated by a plus or a minus. That's all it is. Okay. So anything can be a term, like the constant, the 10x, the 10x squared. Okay. So the one with the coefficient with the highest power is the 10, right? So leading coefficient is just 10. Okay. We're just reviewing. Is that any questions on number 1? I'll give you some notes on end behavior. If you have an odd degree and positive, you know, let me see if I can shorten this. Yeah. If I define them ahead of time, we can write less. let f of x be a polynomial with degree n and a leading coefficient a. So number one, if n is odd and a is positive, then you have this kind of n behavior. So the functions, I don't know what happens in the middle, but at the ends of the function, you'll have that kind of shape. Okay. Now, if n is odd and a is less than 0, then maybe I can fit it over here. You'll have this kind of behavior. If n is even and a is positive, then you will have see if I can make this a little prettier. I don't know. It'll just be kind of like a parabola, right? Just the ends are up. It might do a bunch of loops in the middle. I don't know. But we know for sure this will happen at the end or beginning.
So that's how everything like that.
And basically what I'm saying, let's say you have some weird function. Something going on, but if so there might be a bunch of stuff happening, right? But I know that at the end, if it's even and a is positive, I'll have these going up. I don't know what happens in the middle. We just know this for sure. Okay, it's like a hint, I guess. So that's what I mean by end behavior. If n is even and a is less than 0, then that's the opposite, right? Just pointing down. Just the ends. So for the amount of space, I'm gonna add an extra detail for 1 through 4 on the next page. Okay, so I'm just gonna put 1. I guess think about it. As x goes to infinity, you see how this is going upward, right? So as x goes to infinity, y goes to infinity. As x goes to negative infinity, so does y. Do you agree with that? All right, over here it would be the opposite. As x goes to infinity, it goes to y goes to the negative, shoots down. So I'm gonna add those notes for each one of these four on the back. What happens as x grows? What does the function do on your endpoints? You can see it visually here. I just didn't have space to add it. Maybe I could, I don't know. No, I think it looked too messy. You guys cool on this page? In behavior continued. For number one, let's call it part A. As x goes to infinity, f goes to infinity. Part B. As x goes to negative infinity, so does the function. This is n odd a positive. Number two. As x goes to negative infinity, f goes to negative infinity. So just the opposite. So this is when n is odd, a is negative. As x goes to infinity, so does your function. For both, in both directions. So it goes to negative infinity, it still goes up. When n is even and a is positive. Number four, I'll just flip these guys. This is when n is even, a is negative. Okay. Yeah, I think it's best we put it on a separate page. the number of turning points a polynomial will have is n minus 1, where n is the degree. So all these hints that I've given you, all these ideas, well, basically, it's kind of like for so if I give you a graph, you'll be able to figure out, okay, what is the degree given the end behavior, given the number of turns, etc. You can kind of like figure out the answer with all the hints. It's basically what we're doing. Okay. So if I just give you a picture, you should be able to figure out the degree. For sure, figure out if it's even or odd. Yeah. Let me show you what I mean by turning point. Just a moment. Yeah. Hit the share button so I can record it. The homework starts out pretty chill. It says, get the degree, leading coefficient. That's it. Then I'll ask you, okay, well, what's happening with the end behavior? So if you look at it, what is the degree of this guy? Number 2. You guys see it? I don't know if I can enlarge it or not. Yeah, degree will be. I messed it up. I think it reset. Yeah, it's degree 5. Our leading coefficient, what is it? Whatever's on the highest power, right? Whatever number's on the highest power. Yeah, the -1 is there. So I mean, it's negative, obviously. Negative. And the degree is 5. If you look at the notes, end behavior, the second page of end behavior, we said if it is odd and negative, it's number 2, right? Then yeah, if it's negative, it's positive, and this would be negative, right? So that's all they want to know. What's happening at the end? Okay. That makes sense to everybody? Okay. Let me know. Yes.
Oh, wait, okay, so like, let me just put like good and
Yeah, they want to know, is it going to positive? Is it shooting upward, positive infinity, or is it shooting down? That's what it wants to know. So you would put positive or negative infinity with the symbols. This guy, oh, sorry. You're gonna say something?
that case, do you have to? Let's plan first.
Yeah, you probably should. Either multiply it out or just understand that this is degree 2. And you're gonna have a term where that's x squared, right? Also, you could think of it as a parabola.
So in that, like in that problem, the degree would be 2,
Yeah.
and the coefficient be 1, right?
We should remember that all parabolas are moving up. So it doesn't matter what x does, y will always go to infinity, right? The result will be positive. Yeah, so both would be positive for that question. Positive infinity. You can also graph it, it's verified, right? But without the graph, you should know what the stuff we wrote down. Now here, it wants to know what is the least possible degree. So give you a graph, that's all we know. So the number of turns will tell you the degree. So, and we might turn is gonna go turn one and pocket goes up and down. But it also called the inflection points. Turn. So we have two turns. So what does degree be? That's if what do we say? N minus one is the total number of turns. So what would n be if you have? Well, 2 is the number of turns. So it would have to be 3, right? It would be 3 minus 1 equals 2. That gives you the turns. That makes sense? N minus 1 equals number of turns. So the degree will always be one more than the terms. Okay. So if you're given the degree, you would say one less would be total terms. That'd be how you would figure that out. Also, you can see the M behavior too, right? And give you a hint as well. When you think about this, and what's the lowest degree here? Yeah, it looks like 5. Yep, that's all you got to do. Intercepts, we've talked about that. More M behavior questions. I think that's really it for this section. There's some videos there just in case you forgot stuff. We did not talk about multiplicity. Let's talk about that right now. So if it's already factored for you, then you know these are basically intercepts, right? Plug in number 0, you would get a 0 intercept. Here, plug in 8, you would get it on the x, right? Plug in -8, you get another one. But these are all your x intercepts right there. If you don't see it, set it for 0, you can solve each of these, right? See the intercepts, the zeros, same thing. 0 is an intercept, same thing. You're gonna be 0, 8, and negative. Everyone see where that's coming from. Do you remember? Everyone see it?
0, 8, and -8.
You plug them in, you would get a 0. You plug in either of them.
Like to find the x, like if you just solidly has it, it's not.
The second we were supposed to be set from all those things with a 0, and then you solve it. That means 1 and 0, you'll solve it. Next, you give it a 0, and place line of 8, you give it a 0, and it's fine. But the answer 0, 8, negative. See it. Plug them in, you get 0, which is the intercept. But so I can't talk about this unless that makes sense. Is that clear, or do you want to see more steps? Let me know. Okay. That makes sense. So knowing that those are 0, then we can talk about more consistent.
So what is it asking? It's asking if like the R x is like most.
0 as x has okay. So that's such a good question. Find the zeros of each one. Find the 0, then give them this. Basically, look at this term. this zero, which I don't see zero, has an odd ultimate spin. So that would do something to the graph. Has an odd. Let's see. So the zero that is represented here. Points. You would say, okay, 1 0 has 0 has that is 0.
So just the times.
But you just write how many times here and what you have. Get the 0, 0, is that clear?
So for like 1 0
Sorry.
for the first part, like so you get yeah.
So you pick one. So I'm gonna pick the first one, right? It lets me write it. I changed it on me, but that's okay. 0 is 0. Right, I'm choosing this factor.
Yeah.
And it has a multiplicity of 30. That's it.
So then for the second one, it would be
Another 0, so choose one. 7 for this one, right? So plug in 7, this would 0 out. So that's why I'm choosing 7. It has an odd multiplicity of 3. Then you go to the next one. -8. Is it 2? And that's it. That's all you gotta do. Does that make sense? Okay. There is a graphically, if it is even, it'll bounce off that 0. If it is odd, it'll go through that 0. See how these are going through? So this right here is 0. These are all zeros, right? These would all be considered odd multiplicities because it's going straight through. So if it would have like bounced. Zero was here and it would have done like this. Then that would be even multiplicity. So you can tell graphically what type. Okay. And you can count that how many zeros we got. 1, 2, 3, 4, 5 for this made up question. Okay.
So like
It's okay.
So the multiplicity is given just bounces off, but then is it only when it's 3 or when like all the other numbers like
So any odd will cross the 0. It'll go through it. Any even will be there, but it won't go through. It'll just turn around, bounce up. It'll touch it. Okay. So now if you ever forget, just think about parabola, kind of has that shape, right? Even parabola, bounce. Otherwise, cross it. I don't know if that'll come up, I guess. If let's say that it was 1920, right? And we wanted a graph without a calculator, then all that information would be very helpful. So graphing this using intercepts and the end behavior and the ideas of multiplicity, excuse me. Having all these ideas together will give you a really good sketch of the graph. So if you didn't have a calculator, that's what you would do. Yes. Yeah, the highest degree is the most number of zeros you could have, but it's not guaranteed to be that many. So if your degree is 5, you could have at most 5 zeros, but you could have none or 1 or 2. So I can only guarantee you could maximum of 5 or degree of 5. I think there might be a minimum, but I have to look up the theorem. I want to say there's a minimum of one. But anyway. I think that's pretty much it. This guy wants you to sketch it. I think that's gonna turn into a pain. Not gonna worry about that. Okay. That's pretty much it for those two sections. Do you have any questions on those ideas? And we'll stop here. If you want to work on some homework. I'll open most of the sections up one more time. If you want to improve your grade, you can. If not, I would work on the new stuff.